In this video, we're going to be finding the equation of the line that passes through a given point and is parallel to a given equation. All right, so let's say we're given the equation y equals 3x plus 6. And we want to find a second line that's parallel to this line and that travels through the point -2 and 7. Okay, so we're looking for a line that's parallel to this one, which means our two lines will have the same slope. That's the fact that we know about parallel lines. They have identical slopes. Slope-intercept form tells us that this 3 right here is our slope for the line 1. So line 1 has a slope of 3, and since we're looking for a line parallel to this line, we know that the slope of line 2 is going to be 3 as well. All right, now here, in the previous video, we've been plugging into our slope and our given point into point-slope form. Let's go ahead and use the slope-intercept form now just to show that we can use either one. So our slope-intercept form is such: y equals mx plus b, where we know m is our slope and b is our y-intercept. So this is the form we want to use. It's actually the same form that's used for our first line, so that means it'll save us a little converting at the end. We won't have to change from point-slope form to slope-intercept form. So let's plug in our given information into our slope-intercept form. So we have y, which is 7, equals mx, which is 3 times x is -2, plus b. b is the y value of our y-intercept. So we have 7 equals -6 plus b. b is what we want to solve for, so let's go ahead and add 6 to both sides, giving us b equals 13. Okay, this is the only last piece of information that we need, so now let's go ahead and write the general form and slope-intercept form of the equation of the line that is parallel to this one and passes through this point. So we have y equals, our slope is 3, so 3x plus b is 13, and here's our equation of our second line. Okay, not a whole lot to it. We're just basically using what we know to find a second line that's parallel to a given line and passes through a given point. Okay, let's take a look at the next one. Let's say we're given the line, or the equation of the line, 2y plus 1 equals 0. We want to find a second line that's parallel to this line and that passes through the point 5 minus 3. Okay, this equation is actually in standard form. It's just missing the x term. And this should tell us that our slope is 0 because, well, the only thing that can make x go away is being multiplied by 0. In standard form, standard form is ax, we should know this by now, plus by equals c. And our slope for this form is m equals minus a over b. And the only thing we can multiply x by to make it go away is 0, so a must be 0, and which would give us a slope of 0. 0 in the numerator is perfectly fine, it just makes it 0. So the slope of line 1, or m sub 1, is 0, and since we're looking for a line parallel to this line, the slope of line 2 is also going to be 0. A slope of 0 means we have a horizontal line, so we're looking for a line that's parallel to this one. We're going to have two horizontal lines. So let's plug into our slope-intercept equation and find out what that equation is. So slope-intercept form, let's isolate this. Slope-intercept form is y equals mx plus b. So we have y, which is -3, times mx. M is 0. Let's go ahead and just write it out for clarity. X is 5, so 0 times 5 plus b. b is the y value of our y-intercept, and that's actually what we want to solve for, so let's go ahead and do so. We have -3 on the left side. 0 times 5 is 0 plus b, and we just have b equals -3. Okay, so now we have our y-intercept and our point, and our slope. So let's go ahead and write the general form and slope-intercept form of the equation of the line that's parallel to this one and passes through this point. So we have y equals mx, m is 0, our slope is 0, so that cancels, so we just have b, which is minus 3. So this is the equation. It's actually both in slope-intercept form and in standard form, if you want to look at it like that. It's the equation of the line that's parallel to this one and passes through this point. So it's actually a little difficult to see because this looks like it's definitely not in slope-intercept form. It's actually in standard form, but this is also in standard form. It just doesn't have an x because our slope is 0. So this line is a horizontal line that passes through the point y equals minus 3. It's a horizontal line going about y equals minus 3, and this is a horizontal line that is parallel to this line. So good to know, so we don't have to actually graph these, but even if we did, these would be fairly, we can have a general idea of what we're looking at. Okay, we have time to do one more. Let's look at the equation of the line 4x minus 2y equals 6. And we want to find the equation of a second line that's parallel to this line and that passes through the point minus 1 and minus 10. Okay, so we're given the equation of the line in standard form. Let's go ahead and start by simplifying things. Simplifying makes a bit easier. All these terms have a factor of 2 that we can divide out. So this is going to result in 2x minus y equals 3. Simplifying makes things much easier, including our calculations. The standard form equation, we know that the slope is minus a over b. So we have the slope minus 2 over b. b is a minus 1. It carries the operator. So minus 2 over minus 1. The negative signs cancel. And our slope for line 1 is just 2. And we're looking for a line parallel to this line. So the slope of the equation of the line, the second line that we're looking for, is also going to have a slope of 2. All right, so let's use this along with our point to solve for our y-intercept. Let's see. We have y equals mx plus b, so y is minus 10 equals our slope, which is 2, times x, which is a minus 1, plus b. All we need to do is go ahead and solve for b. So we have minus 10 equals minus 2 plus b. We simply add 2 to both sides, which gives us b equals a minus 8, adding 2 to both sides. And since our first equation was given in standard form, let's go ahead and write this answer. Let's go ahead and write it in slope-intercept form first, and then we can convert it to standard form. So we have the general equation y equals m is 2, so 2x plus b. b is a minus 8, so we have minus 8. And let's go ahead and convert it into standard form. We can subtract both sides by a negative 2x, so we have minus 2x plus y equals minus 8. We never want our leading coefficient to be negative, so let's go ahead and divide everything through by minus 1, or multiply everything through by minus 1, however you want to look at it. These negatives cancel, as do these. We're left with positive 2x minus y equals 8. And that's the equation in standard form of the second line, the line that's parallel to this one and passes through this point. Okay, so not a whole lot to these. We just want to remember that to find a parallel line, the slope of the two lines are going to be identical, and we don't want to forget our different forms and their characteristics: slope-intercept form, standard form, as well as point-slope form, which we use extensively when we were trying to find a second line that was perpendicular to the first. That was in the previous section. So go over actually both of these sections for parallel and perpendicular lines, because they actually make graphing much easier, and I'll see you soon.